Sorry, we're starting a bit late because, like we said on the general group, we want to be conscious with time, but sometimes technical issues. But I want to believe that going forward is going to be a lot better. So once again, can this one? Look, I'm waiting. Hmm. So the essence of this training, we will try as much as possible to carry everybody along. And what we mean by carrying everybody along, it's your regardless of your cadre, in beginners, advanced, and anything in between, such that you will be able to learn. At least at some point, you'll be able to understand. And the training is going to last for about 3 months, but it's going to be Saturdays alone. So because we want to do it such that you will be able to we will be able to touch on vital parts of sound, and so that it will really be impacting, and it will not just be a surface thing. And trust me, by the at the end of the training, if you follow consecutively and if you really put your effort and your mind into it, trust me, you'll be able to and get something that will pull you through and beat your chest as a sound personnel. So I'll be taking us on on several topics, maybe for the next 3 or 4 Saturdays because we have other facilitators too. But this morning we're going to be discussing overview of audio technology, techniques, audio production techniques, and microphone technology. And straight I will go into because the slides are a bit long, but we will try to cover as much as we can. Now, what is audio production? It is the process of creating, recording, editing, mixing, and mastering sound for various media, including music, film, TV, podcasts, video games, and live performances. It involves both technical and creative skills to produce high quality audio content. The definition is a bit long, but at the same time, it's just a line, which is the creating aspect. So when it comes to audio, creativity is involved, not just your technical skills. Yes, the technical skills is fine, but you have to be creative at the same time. You have to be creative. And the audio production, for the sake of this course, we'll be doing much of live audio. However, when we talk about audio production, we have the studio aspects too. It's not when you talk about audio production, it's not for live alone. It's also we also have the studio aspect. That's why when we talk about sound and audio, it's a bit complex sometimes. It's wide, it's large. But for the sake of this call, we'll delve more on the live production. Not even with the advent of AI now, that music production, people are beginning to create music in their homes using AI. We might also get into that. So you can see the various aspects of audio: music, film, TV, podcasts, video games, live performances. Virtually anything in this world, when it comes to production, there is sound, there is audio, sound. I'm talking now, I'm generating sound. Now there is this confusion or complexity when you say sound and audio. Who can tell me the difference when you say sound? Like I was in an interview panel recently, and we were interviewing this engineer, and he kept saying he's an audio engineer. So I wanted to bamboozle him And I said, are you a sound engineer or you're an audio engineer? And I got confused. So both terms can be used interchangeably. However, I want to ask here, who can differentiate? Because there's still a thin line between sound and audio. So who here can differentiate? Anybody? Hmm? Yeah, try. Okay. Okay. Good. I like that process. You got it. You got it. So that's just the difference. Sound is natural. It's acoustics. What I'm saying now is sound. The music, the vibration of the music we can hear from far, the low end, it's sound. But when it becomes audio per se, it's after it has been processed, to be recorded and all of that, and then it's now audio. So, however, you can still use both interchangeably. But I just want us to know that there is a distinction. So let's proceed. Okay. So key stages of audio production. So here in this section, I will just this is more of the this is more of the studio stuff. So we have 5 stages basically when it comes to audio production: pre-production, recording, editing, mixing, and mastering. So the pre-production is the planning stage. It's the planning stage where you have where you plan for a project, a film, a podcast, an interview. So you want to have an interview. Okay, you don't just get into the job. You plan for it, so that you don't get into it and you now discover that there's something missing. Just like we did this morning, all these things didn't just appear here. So you might not be able to write everything. Just get the major points so that you will not be distracted. And there is a planning process for all this to come together. The mixer, the this, the that, the monitor. So there is a planning process. Then writing, that's for the music production. You have lyrics. That's why you have some musicians, they don't really write. Somebody writes for them and they turn into music. So they make music out of it. It's so then selecting your DAWs. Your DAWs, DAW, that's digital audio workstations. Then your microphones, your instrument, everything that you need for uh, for your production. Setting up recording sessions. Then the second aspect is the recording. We call it recording or tracking, because when you are recording, you are tracking the event, you are tracking the production. So, and what do you use to record? Especially like I said, at this stage, this is for studio, majorly for studio, not the live sound. So you capture with using microphones, MIDI controllers, and MIDI controllers. I wanted to get the MIDI controller here this one, but I think before we end the class, I will show you a MIDI controller. Your ensuring clean recordings. Your recordings has to be clean. So because like we say in sound or in audio, um, a clean recording is better than trying to use your editing skills. What am I trying to say? Is that once you have a good recording, the environment is fine, the ambience is fine, everything is fine, and you record. Your editing will just be a walkover. What will be a walkover? You don't need to stress yourself. Start chopping, removing this, removing noise. Because by the time you are removing noise, and when we get to frequency, you understand that when you are removing noise from what you have recorded, the system, the mechanism does not understand noise. It understands frequency. So when it's removing those frequency, those noises, you are also removing the vital parts of your audio. That's why you listen to some audio, it's not rich, it's not full. You don't have that full spectrum because you have chopped off the vital aspect. So it's better you have a clean recording so that when your production is out, you have the full spectrum of what you recorded. So we'll also get into that when we get to editing. You understand what I'm saying better. So then common recording sources. You have the vocals, your instruments, then Foley. Foley is a sound effect. What is Foley? Foley is recording using recording, like taking samples. For example, you are watching there's a movie being recorded, but they want the sound to tally with what you are watching. So they get samples, they do some recording backstage or back studio, they match it with the video. So later on, I'm going to play a video for us so that you see how they do those things. Whereby when you watch a movie, somebody is stepping, and you can hear the sound of the shoes, even as the shoe is departing. As as the walk or the walk is departing, you hear it. They fade in, fade out, and all of that. So that is fully creating sound effect. Then your editing. Editing, I talked about the editing, but the person that will take us on recording, because there's a course on recording and editing, you delve more into the editing aspect. Then your mixing, of course, applying EQ, balancing your mix. You record you are recording for a music production. You have keyboard, you have bass, you have the vocals, you have the lead vocals, the backing vocals, and you want to blend everything. One must not be louder than the other. That's where the mixing comes in. So then the mastering is to polish the whole thing, to polish the whole track, what you've recorded. But like I said, when we get to recording, then we'll deal with this better. So those are the 5 stages. Now, tools used in audio production. We are still on the studio aspect. So okay, I talked about the digital audio workstation. What is digital audio workstation? It's the software, just software. Don't ignore the big grammars, but it's good for you to understand the terminologies. So when you are talking like a professional. We are using our terms. So when we say DAW, it's not DOR, it's DAW, digital audio workstations. And what are the audio workstations? It's just your recording software, your Studio One, your Logic Pro, Ableton, FL Studio, and all of that. So those are the examples of. And basically, you don't have to know. In fact, you don't have to know all the how to use all the softwares or the DAWs, but at least you know that you are good at one or two. So it's allowed. Then your microphones, your condenser, dynamic and ribbon, different type of. That's for the sound sources you are capturing. That's what you can use to capture voice or capture sound. Basically, your microphones. And we are in this. We are going to do. We are going to get deep into microphones in this section, so that going forward, when you are recommending or when you are in production, you will know what mic to use. And if you have been having issues, you know how to tackle it with microphones. So audio interfaces. What does the audio interface? Convert analog signal to digital. For example, your sound card is an audio interface. In the course of this course too, there is a course on audio interface. So we get your plugins. Those plugins are basically virtual instruments. They are also software, but we use plugins to edit, to manipulate, and all of that. And we will also get your the person that will take you the recording to get into that plugins. Why I'm brushing through this aspect is because I want to deal with the live section, but I just want us to carry this. I just want us to have idea of this, and you will be able to see the relationship between the stage and the live. So your studio monitors and headphones to monitor, basically. So applications of audio production, yeah, we've talked about it. Music production, film and TV, your podcast and radio, game audio, live sound. So key stages now, I want to go into the live production. Key stages of live production. So live audio production involves multiple steps to ensure clear, balanced, and professional sound for events like concerts, conferences, theater performances. Now, when we talk about live production, it's not about short setting alone. It's not about concerts alone. Basic, what is it called? Conferences are also part of live production. What the difference between studio and live is that live is real time. Is real time, and you have audience. unlike studio, you might not have audience. It's just you and the engineer. You can make mistakes in studio and you repeat, you edit, you cut, you join, but you don't have that opportunity in life. That's why when you are doing live production, all your attention must be open. You can't afford mistake. For example, you're having a show and the production have started, and you don't discover halfway that you forgot to press record on your production. That is a disaster. I like that. It's a disaster. So that is the difference between, if it's studio now, let's repeat this. Mhm. And at the same time too, you have to be careful too when you are in when you are in the studio, because sometimes those musicians, it's just that the advent of AI and some several public plugins that are coming in, so there are many cheats going on now. Those days, some musicians, they just have that inspiration. They just walk into the studio and they start dropping. I learned of one of a famous musician. If I mention his name, you will know him. He just got in studio. In fact, it's Majek Pashak. He got into studio, and so and he was in high spirits, if you know what I mean. So and he started singing. And so there were two engineers. So the man on the board, he was just there, and the guy got into the studio booth. So the other engineer was telling him that, I hope you have started recording. He said, no, it's just that the guy is just he's just he's just freestyling. He's just freestyling. So after like 10 minutes, the guy Majek now got out of the booth and said, let me listen, engineer, let me listen to that shit. Play that shit. So the engineer said, he just did like this. It's not funny. The guy's eyes just went blank and turned immediately. In fact, he stoned the engineer. It was a serious problem that day. So what am I trying to say? That when you're doing production, you don't assume anything, because the guy had the inspiration that time. He might not be able to go back in that mood. And we will discuss, yes. And we will also discuss that the psychology of doing all this. Your client must be in the mood. You can't be an engineer and you'll be quarreling with everybody, or you're on studio and on stage, working on stage, and if they can't hear themselves, make them hear themselves. If you need to talk to them, okay, this, you guys need to work together, because sometimes some musicians will just come up with the sound is bad. The sound is not actually bad. It's because he couldn't hear himself, or he doesn't even like your face, or whatever. But we'll deal with that aspect later. So what am I trying to say? Studio and live, they are different things. They are different things. So you have to pay. Or the musician got up. A musician got up on stage, or a pastor got on stage, and you discover that his mic was not turned on. It's not because it's an engineer that actually dropped that mic or passed that mic. So there must be communication, so that there won't be any break or dead time in your production. Well, that's so. Beside that's a T112 audio console. It's a digital audio. It's Allen and Heath, and that's a stadium at Ibadan. I went to do a job sometime back. So when we get to digital mixers. So now we are back to our how we started in the studio. Same thing with live. So we also have basically 6 stages too in live production. Your pre-production. So you determine the type of event. A concert setting is different from a speech setting, whereby a conference is different from a concert. A concert, you have musicians, you have instruments, multiple instruments, and all of that. So you can't, the same effort you put into the type of effort you put into a speech event is totally different from the type of effort you put for a concert. They are different ball game entirely, different production entirely. So you need to assess it. You need assessment. You identify the sound requirement. That's why when there's a show, the first question we ask, what kind of show is it? What kind of event? Do you have a rider? Bring us a rider, especially when it's a music show, a concert. So you also assess the venue. Don't assume the client will say, I just 2 people, just 50 people coming, it's just 100 people. You sometimes, so that you don't under prepare or over prepare. So it's also good to visit the venue, and also the acoustics too. Acoustics is the physical properties of the hall, um the reflection. When we talk about I'm trying to bring it down to a BRS minimum for you to understand. When we say acoustics of an environment, we are talking about um, the reverberation of the hall, the reflection, and the reflection of the hall, whereby, because some hall, when you speak, you hear something like echo, like delay. And there are things. It's physics. There are elements. Yeah, there are elements that causes that. So, for example, in sound generally, sound is not friendly with shiny surfaces. It's not friendly with shiny surfaces. It reflects. So if there is a venue like this and all the walls is marble or tiles, there is a problem already with sound. By the time you install sound in that kind of environment, you won't hear each other. It will just be howling. Yes. So the acoustics of the venue, it's very important, so that you need to make your necessary advice and put some things in place. These things that you see, they are not just designs. Some people might think it traps standing waves. It's called wall panels. So sometimes it's been suspended. You get some venue, you just see some things something is floating. You think it's designed. It helps to trap sound, to trap frequency, to trap waves, such that you don't have those. So that when we try to deaden the room as much as possible, so that when I speak, my word does not reflect, does not bounce back. Because, can you hear that? Do you hear that? A very bad acoustics room, you will hear that clap like 2 or 3. It will be traveling like that. So now imagine, it's just a clap. Now imagine 10 people clapping, keyboard playing, everybody singing at the same time. It's a disaster. And if you have been into that kind of hall before, if you have had that experience, you will understand better what I'm saying. So these guys are not designs. So it's deliberate. So that's why we have, it's also the reason we have rug here. Yeah. But however, we human beings too help to absorb sound. So yeah, when the hall is full and even the acoustics is bad, it tends to help a bit. It tends to help a bit, because everybody there must have trapped one frequency or the other, so it doesn't reflect. I was taking my time on that so that we understand the importance of acoustics of um of the event. So if it's outdoor now, you don't have problem with reflection. Nothing is reflecting anything. If it's an outdoor, it's an open event. Now, equipment selection, your microphones, vocals, Shure SM58 dynamic, Shure SM57. Please help me get SM58 and SM57. So then your PA system, your main speakers, FOH. We call FOH front of house. This is FOH. Wherever your mixer is facing your main speakers, it's your FOH. That's the term we use, front of house. We have FOH, we have stage. So you get used to those terms. Your PA system, that's basically public address system. Your monitors, these wedges, either wedges or in-ear monitors. So your mixing console, either analog or digital, but analog is going, it's being phased out. So your signal processors, EQ compressors, and all of that. Then stage plots. Oh, so this thing has caught something now. Okay, stage plot and input list. Stage plot basically is how you arrange your stage. So the essence of that is that it will help you. You have a diagram whereby your input you would have tracked. You have a kind of schematic diagram. So with that stage plot, any engineer you hand over that to knows you don't have to be there. By the time you get to the venue, everything on that paper is reflected physically. So it's just basically the positioning of your equipment on your stage. Basically your monitors, your I/O, or your audio splitter and the rest of them, and your cables. So stage setup, positioning, mic, these are basically straightforward. You're running your cables, proper cable management. This is very important, cable management, because when fault shows up, it's easy for you to track. But if your cables, and I will show you some pictures. So PA system, your main house, your subwoofers, if needed for bass reinforcement. Then check for power distribution to avoid noise and interference. Try to use separate power from lights if it's possible. Sometimes you hear humming, it's because of power. Nothing is wrong with your sound. It's power. But it's difficult for you to explain to a non-sound person or non-technical person. They won't understand. But uh, that can be very disastrous. So most times it's better for you to, if you should be on the same face. You can be on the same face with the video guys, with the camera guys, but not with lights, not with lights and screen. That screen have to be separated. So sound check too is preparation. Where there's difference between sound check and line check. Line check basically is for you to get to know that okay, you plug your mic, you have it on your, you can see the microphone, but it doesn't mean the microphone will sound properly. Well, at least you have the signal. You are sure that you have the signal. So it's when you do sound check that you can now EQ the mic. So then live mixing during the event. So when you have done all of that, you do your mixing, balance levels, apply EQ. Now, when we get to mixing, we are going to a course. Maybe that will be next Saturday or so. It's mixing. So we'll go deep into this EQ thing and compression thing. We'll go deep into that. So we have monitor mixing. That is for your stage and your troubleshooting. Troubleshooting to reduce EQ spikes, reposition mics, handle dropouts. A signal is breaking and all of that. So you check your cables and your frequencies. So look at cable man. You can see that engineer is messed up already. So there's a problem. How do you trace this kind of? How do you trace this? You can't. Okay, thank you. I'm coming to that. Then sorry, sorry. That's you help me bring either the mic on stand or that's your that's your audience mic. Oh, fantastic. So you can see this. Your cable needs to be well laid out, labeled. If there is a problem, you can easily go there, unplug, or you can trace. But with this, till the show ends, you can't trace anything. You can't trace jack. Trace that. Even if you are the one that did the setup all by yourself. So cable management is important. So look at this. This is a proper cable management. It's even labeled. You can see front, center, surround, and that for those that have gone into our Ampum, this is how we label it. We can track anything. Even at FOH here, we can track something. So proper cable management. I have to put that there because so that you know the importance. But the fact that you plug your stuff and everything is working is good. It's fine. However, if a problem shows, and that's one of the major challenges of life, you can't tell everybody to wait. Let us. If the event must continue, so your ability to think on your feet, your ability to resolve issues, your ability to have another plan to kick in the next plan goes a long way. So post event, after your events, you should be open to feedback, then review glitches so that such will not repeat itself. By the time you do some review, you ought to know, okay, oh, so this is what we faced. It's important. I remember an event that we did at our Alimosho Center last year, Excel. I think another version of Excel is coming up next month. That event, we had prepared and done everything. We went for there was supposed to be drama, and we went there. So before the event, the talents, the actors, they used the mic. We tested. Though we didn't run the event per se. We didn't run the rehearsal. But what we just did was line check. Okay, talk. We can hear. We can see everything is fine. So but what we did was that that center has their own established system, their own established connection, which is a mixer with their their own, and they use an M32 board. So we didn't want to come there because of the short time and all of that. We begin to introduce our own mics for the drama. So we went with another mixer from here to create a sub mix so that all the mics for the drama, we plugged it into this mixer we went with, so that we'll just take one output, the final output from that mixer to the existing mixer in that hall, which is a good plan. So, but when the show started, then all of a sudden we couldn't hear anything from the main house, but we were seeing signal on the board we went to. We were seeing the signal, the microphones. We were seeing everything. But we can hear them. You can hear it with while when you pre-fade and when you solo, rather, using your headphones. So at the end of the day, it was a mess, because now the show has to continue. So those guys, we started passing handheld microphone, which was not the plan, and it was bad. But we suspected that it's the cable that we ran from the art mixer to the main mixer from the hall. We suspected it, but the cable was right in the middle of the auditorium of the hall. So you can't be unplugging cable and doing that. So, but for such, if we had run like 2 or 3 cables to create redundancy, it wouldn't have happened. Or we'll just switch to that one immediately. So those are the steps. So when you're done with event like that, you sit down to check, In fact, before you leave the venue, it's good for you to check what happened to this thing. Let's track it. Though that day we could not stay behind because we had other assignments. So what I'm just trying to say is that you create alternative measures, and you note any issues and feedback. Okay. So now, audio spectrum. This part is very, very important in sound. The audio spectrum is the range of frequencies that humans can hear. And basically, it's range from 20 hertz to 20 kilohertz. Or you say 20 hertz to 20,000 hertz. It's the same thing. Kilo is 1,000. So that is basically, if you are a complete human being, permit my it's expected that you should be able to hear or feel from 20 hertz to 20 kilohertz. But some of us, our auditory, because life has even dealt with us in the first place. So you think you can hear perfectly, but you are not hearing. And as a sound engineer, and as audio personnel, your ears are your first tools. Your ears are your first tool. If you don't have ear, that's all. If you can't hear, you can't do sound. How? Can't do sound. or what you will do is limited. Let me not blank it out outrightly. Uh, it's limited. And so, because sometimes here, you say, can't you hear that? Some engineers will hear, some will not hear. Some people will be looking at what are they hearing? Yeah. what, are they, what are they hearing? We see that a lot, but it's allowed. It's allowed. Like last week, for the past 2 weeks now, we've been hearing this like a digital noise on our keyboard. You see, it's when you have good ears that we hear it. So, and you need to hear those things, because especially if you are streaming, what you cannot hear on your main PA system, you will hear it online. And if you have a studio, if you are the type that you have a separate setup, a separate room for mixing your online audience, where you have your near field monitors, you are going to hear everything. Sometimes the man Timoni that does our mixing here for our broadcast, sometimes you will come here and say, can't we hear? You can hear something. There's a noise. There's this. We are not hearing anything from the main PA, but he can hear, because because those things are close to him. We call them near field monitors. So you need to be able to hear, because those things can be distracting, and you don't want your audience to be distracted. So basically, most sound that you hear is between 20 hertz and 20,000 hertz or 20 kilohertz. Your music, your everything, and everything falls in between. So that's why I said sound is about frequencies. Once you master this, you are good. From experience now, some of us can hear something and say, cut 250, remove 250 hertz. That thing, remove 500. So, and by the time you just go to your board and just find 500 and you deepen it, that thing will go. Because we have been used to it over a time. I couldn't prepare for that. If not, I would have played pink noise for you to sweep. Okay, you have a question. Hertz. Hertz is the unit of frequency. It's physics. If you have done physics in your secondary school, hertz will not be strange. I say if you, but it's a unit of frequency. But it's fine. In fact, some of the best engineers we have now, they never did sciences in India. So that's how life works sometimes. Never did it. Some people did microbiology. Okay, well, it's still science. I won't call names. Some even did Greek, but now they are in sound and they are doing well. Yeah. So this is divided into different frequency bands, each affecting how we perceive sound. Understanding the audio spectrum is crucial for mixing. You can see that, underline that word, crucial. It's crucial for mixing, mastering, sound design, and audio engineering. And so your understanding that spectrum is very, very, very important. And so we have higher frequencies, above 20,000, or we don't. By the time it gets to that, so maybe you are a spirit, you won't even hear jack again. Your ear won't hear jack. But I think there are some certain animals that have the ability, dolphin and bats. If you put a bat in this room, that's why you cannot see. Its ears are so sharp. It tracks frequency to be able to know where there is a path that it can pass. And dolphin too, they have smarter hearing this thing. Then below 22, it's more of vibration. The vibration will get to a level that you can't hear. And some, before you get to that 20 hertz, you feel it. That's why when you are sitting in front of a subwoofer and they pump that and they push that in, you feel it on your chest. And it gets to a range. it gets to a time that you might not even feel anything again because of the level of vibration. But I think elephant can feel something lower than that. So um, the audio spectrum breakdown. So what I've been saying, so this is the cheats of sound. In fact, if you don't know anything in this class, you can track this. You can post anywhere. So we have your sub bars. Your sub bars is subwoofers, and that's what we have under the stage. If you go there, it's buried there. So when you hear those low ends, somebody is playing a low end instrument like your bass guitar, that's where the thing comes out from. Then that is between 20 hertz and 60 hertz. So your bass is from 20 to 250. Imagine putting your mic, you are using a microphone and you are enhancing 250 hertz on that microphone. It's just rumbling that you'll be getting. And that is why sometimes you get to some events and you are hearing all those rumbling, you are hearing those things. Because the engineer that doesn't know, he has boosted what he does not need it. You don't need to use 250 in that in your voice. You definitely don't need it. So you need to know the things. So that's why when you use high pass filter, you remove all those things you don't need on that channel. Once you don't need it, remove it. By the time you remove, you add here, minus here, add here, minus here, your production will come out clean and fine. So low mids is between 250 and 500, and that's the mod zone. The mod zone. When a mix is muddy, when the sound is muddy, go and check your 250 to 500. If something is not good. Though there are some instruments that should be present there. However, you might not need it. So mixing tip, they all have the tips. Like the mixing tip for the low mid now is cutting here. Cutting here can clean up a cluttered mix. So by the time your sound is sounding, just go check your low mids. Something you have boosted, something that you should not boost. Then your mids between 500 and 2 kilohertz. Your upper mids, because we have low mids, we have high mids. Especially for high-end boards, you will see all those things on your EQ. When you get to mixing, we'll still come back to this and we'll deal with it. Well, I know everybody wants to mix, everybody wants to touch the board. But there are some basic principles. And once you know these principles, those things are machines. They're machines and they only understand numbers, binaries, frequencies. So once you tweak the right numbers, the right digits, you'll be fine. So it's not rocket science. All those your knobs, they are potentiometers. If you did physics, basic physics, potentiometer will not variable resistor, and it will not be strange to you. You are adding some amount of current and all of that, and you do that. So then your upper mid, your presence. Sometimes you say, this thing does not have presence. The brightness. So that is your 4K, 6K. So we used to have one of our engineers that we teach back then. He's good with all the frequency things. MMJ. Mix Master J. MMJ. He will just sit down there and say, add 2K, remove 6K. Oh God, you know. But most of the time, he's right. And he's more of a studio person. And that's on that good thing. If you have stayed well in the studio, if you have worked in the studio very well, by the time you get to live, you just translate that into live. It's the same principle, basically. The only thing that you are doing it live and it's on the spot. So it gives an edge. The only thing about studio people most of the time, they get carried away. They've forgotten that it's live. They just put their heads down, focusing on the board. Somebody else has mount on stage. Focus on one line. EQ. They want to EQ. They want it to sound like the studio thing. And by the time somebody else is on you forgot to open the mic, so they don't look up. You normally have challenge with the studio people. They're always looking down. So that's that about the spectrum. When we go to mixing, we'll understand more of it. So why does audio spectrum matters? For balancing your mix. Knowing which frequencies clash helps avoid muddiness or harshness. Then sound design, your synths, EQs, filters, shape sounds by boosting or cutting specific bands. Mastering also, it ensuring all frequencies are well represented for playback or on different systems. Now we're coming to microphone. So, okay, we're doing well with time. What is a microphone? It's basically, a microphone is a transducer, just like a speaker. It converts one form of energy to another. So a microphone is a transducer that converts sound waves, which is your acoustic energy. What I'm saying, I'm producing acoustic energy, I'm producing sound. So a microphone picks that up, it picks out, or it picks out, or picks that up as a vibration. So then it now converts it to electrical energy. That is what a microphone does. And the speaker does the opposite. That one converts electrical into sound or into acoustics. So basically that's what, and it's an electrical signal could either be analog or digital for recording, amplification, or broadcasting. So microphones are essential in music production. Your vocals, your instrument, film or TV, dialogue, foley, broadcasting, radio, podcast, live sound, communication. Your phones, all these phones has microphones. Sometimes when you talk and people don't hear you, the microphone is bad. Though it takes a long time before the microphones on phone just go bad. Yeah. And sometimes it happens. So they all have microphones. And we are going to delve into different types of microphones. So how does the microphone work? I've explained that. That's the sound wave going into the microphone and coming out as a signal, as an electrical signal. Types of microphones. This is where engineer needs it. Type of microphone is different from the polar pattern of the microphone, and you will get it. You understand what I'm trying to say. Now we have basically three types of microphone: dynamic, condenser, and ribbon. And I'm going to explain everything. So your dynamic microphone use a moving coil in a magnetic field to generate signal. A dynamic microphone does not need power for it to work. This microphone, by the time I plug in an XLR cable, it will just work. It doesn't need battery, it doesn't need any power. Or we can say the power is negligible, so minute. So it doesn't need power to work. But a condenser mic on the other vein, the condenser mic uses phantom power, and we'll come to that. You see the differences. So this is an SM58 mic, arguably the most reliable microphone in the world. SM58. This microphone, I use it to achieve a lot. I use it as a vocal mic. I can use it as an instrument mic, and I'll still go away with. I can use it for my kick, and I'll still be fine. Mm-hmm. So SM58. Then this is SM57. This is an instrument mic. So if you use your instrument mic for speech, doing a rounding, and you might not achieve that thing. This thing does not sound the way I had it. Maybe the microphone is part of the issue. Or you use the condenser mic where you are not supposed to use. And you will see the differences and the pros. Like now, one of the pros of a dynamic mic that is durable. It can handle SPL, that sound pressure level. When you shut it on it, it can handle it. A condenser mic will not handle that. It will now begin to sound harsh, now begin to distort. But this guy will handle it. No external power needed, of course. Then, but now it also has its own kind of deficiency. It's less sensitive to high frequency compared to condenser. It's not bright like condenser microphone. So, so that is that about microphone. So then the condenser microphone, I've talked about it also. We use a charge diaphragm and backplate. It requires phantom power. It's best for studio vocals, acoustics instruments, and detailed sound capture. If you want to capture sound, you capture it well when you use it because it's very sensitive. When you use a condenser mic, you want to ask a question? Yeah. This, these are people. Yeah, you're advanced. Yes. Yes. Oh, I just gave example. It's not. It doesn't have to be sure. Sure is just a company name. It's a brand. It's a brand. Yeah. Sorry. It's a brand. We have AKG. We have what are their names again now? Sennheiser, Biodynamic. We have different products, but Shure is one of the leading products in the world. Shure, Sennheiser, AKG. Yeah, at least I can vouch for this product. DPA, DPA microphones, Audio Technica. In fact, there are a couple of good products. Good products. But around here, Shure is Shure is Shure. Sure, sure, because sure they've done their technology so that they can be expensive and at the same time rugged, rugged. Yeah, it can be rugged. So that's one thing. Sometimes they are affordable with their own counterpart. What I will achieve with what I will achieve with this guy, if I want to achieve with some other product, I might spend more. Yeah, I might spend more. So that's just basically the idea. But sometimes, as an engineer, just know what works for you. Just know what, understand what you are using, understand your tool, understand your tool. So if you like, sometimes come with your expensive gadget. With my little, in fact, I can go with a small analog board and I'll still achieve good results. Understanding the gadget, and that's why you need to understand those principles, those frequency things. Once you understand those things, regardless of what you are using, you still maximize it. I'm not saying we should not go for high-end equipment or those high technology equipment that is not they are not relevant. They are very good and very relevant. However, well, just understand your gadget because even if you are using those high-end equipment and you can't use them well, you can't maximize it. And what's the essence? What's the essence? So, so that is what basically what I'm saying. So, the cons of condenser mics, they are fragile, can distort with loud sounds. I said it the other time. Can distort, and that's a condenser microphone. Yeah. That's an example of condenser microphone. Maybe they didn't turn on the phantom power the other time. Maybe that's why it didn't work when they gave you. So if you don't power it, it will not work. It will not work. So, oh, for people online, okay, that's why I was advising that if people can make it physically, but because by the time we do some practicals, we might not be able to balance it with those online. So you see examples of condenser microphone too. AudioTechnica 80 2020, the budget condenser, because condensers are more expensive. They're generally expensive than dynamic microphone. AKG. And so that's the condenser mic as well. Then ribbon microphone. Most times these are used for broadcast and for for instruments. For instruments. So best for warm vintage sound, extremely fragile. Extremely fragile. So those are ribbon microphones. Then lavalier microphones. Now, don't get it twisted. You can have lavalier. I just put this under types. However, you can have a lavalier microphones. Like this one I'm using is a lavalier microphone. You can have lavalier microphone that is dynamic or condenser. So, like this basically it's a condenser because you have to power it. Do what I'm using. It has a body pack. It has a body pack with battery in it. This is a condenser. I mean, this is a lavalier microphone. Oh, okay. So, the body pack. Okay, body pack. Let's see. This is a Shure ULXD microphone. It's not cheap anyway. Not cheap because the other downside to this thing is that you can't run away from spending money on some of these things. Yes, we have other lavalier microphones that are far lesser than this. However, when you get to a big setup as such, and then you will now begin to see issues, maybe frequency jamming and all of that. Because some of those low quality products or low end products or entry level products, when they get to a main show, you just discover that this thing that was working fine cannot work again because other frequency, other interactions are now going on in the room. The screen is transmitting its own signal. We have like maybe over 50 microphones on stage, so frequency comes to play. But these guys, they find their way around, especially when you use a workbench and all of that to adjust your frequencies, because all these things work on certain frequencies. So you can't downplay. Then small, so clip-on mics. That's your live mic for TV interviews and presentations, just like I'm presenting now. So they have the example Sennheiser EW. We have that microphone, but unfortunately I didn't come with it. That one has a smaller, tinier caps. It's very tiny. So, and that's also a good mic. It's not as expensive as this. The only thing is that Sennheiser, I normally have challenges with Sennheiser, with our environment, our region here. It tends to have some frequency issues. You have to be very, very good on with your connection, with your technical capacity, having a good technical capacity to use those kind of microphones. So then we have head one microphone too. You guys have taken that far. Headset. Now, some may say, why headset? Why do you like the other time when they brought the headset? In fact, headset is it's like, oh, okay. That headset I mentioned is not here. It's not here. So the headsets, if I will advise, headset is better for live production. It's better for live, and I will explain the reason. Though it's most of the time it's not comfortable with the ears. In fact, that's why I didn't use it, because of that. Because of the comfortability. It's not for anything. It's best. Why it's best that when you turn your head, the microphone follows you. Here now, when the way I'm turning my head now, I've moved off the axis of this microphone. Move on. Either you like it or not, it will affect the sound. Especially when I remain at that for a long. But because it's quite sensitive, you can get away with it. Then this one too is prone to feedback. Lavaliers are prone to feedback. Before you use it here, you gain structure, fine tune, do a lot, so that whenever anybody is using it, and the person comes on stage, so you're not going to feedback. So those are just the differences. But headset does not have that kind of feedback, so this is the microphone I'm talking about. This is headset. So this is a DPA. I think DPA 4080. So if I was using this now, so I can move around, the microphone follows me wherever I go, unlike the lav. Okay, this is the Sennheiser that I was talking about. Oh, so you didn't get it? A headphone. Okay, that's headphone. This headset, that's headset. So this is the Sennheiser EW112. Can see the capsule very tiny. you almost not notice it. Most times those people that work outdoor, because the advantage of this is that it's a battery powered both for the body pack and the receiver. Unlike this one that I'm using, the receiver is here, behind here, it's plugged into power. But I have a gig outside or an outdoor event. I would rather choose this. Yeah, I would rather choose this because this one is both the receiver and the battery, just put battery and you're off. And most interviews that they do on the street, all of that, none of them use this. You still achieve the same result. So that's the sign answer. Okay, let's with this now. I believe you begin to understand how to make your choices of microphones. Then we have USB microphones now, whereby you just plug onto your system, your USB will power it, and you are doing your presentation. So the example is the Rode NT. Then we have shotgun. Shotgun. This is the shotgun. Where's that mic? It's a condenser mic and it's a shotgun. So this is the mic you can disconnect. This mic, most of the time, they use it for film production and all of that to capture, because it can capture sound from a far distance, and it has a kind of narrow, and I'll explain that narrow thing when we get to polar patterns of microphones, because all these microphones that I'm mentioning, they have polar pattern. You understand what I mean by polar pattern? So it's highly directional. It's highly directional and sensitive. This is very, very small, very tiny. So you can use this for your choir, for audience. Use it for audience. When you watch us online and you hear the people clapping or people, I'm even talking maybe where a pastor, the audience response. Pastor say, praise God, you hear hallelujah. These are the mics capturing them, and the claps, we capture it. So that when you watch online, when you watch online, when you watch online, you have the experience. It be like you are in the room. Then, interesting about a lapel microphone too. A lapel microphone has because it's quite sensitive. So we do a kind of cheat sometimes. When the pastor is using this, without using the audience microphone, this guy also capture the ambience. Capture the ambience. In fact, if you guys are talking there's every tendency that my microphone is speaking, because it's omnidirectional. And when we get to the polar pattern, you understand what I mean by omnidirectional. So when you are making your choices, or somebody say, I give you this mic to go and plug, you'll be able to say, no, I need so mic. You'll be able to differentiate. I understand that somebody has a question online. Oh, okay. It's the same thing. That the shotgun, the condenser is just is a type. It's a type of mic. It means yeah, shotgun is an example of a condenser mic. They are basically the same, but not all condenser mics are shotgun. So I think no, all shotguns are condenser. Basically, yes, basically they are all condenser mic. I don't think I've seen any shotgun that is not a condenser mic, but not all condenser mic are shotguns. Not all condenser mic are shotguns. So that is basically the difference. Okay. Now, microphone polar pattern. This is where we begin to talk about cardioid, supercardioid, hypercardioid, unidirectional, omnidirectional. Those are polar patterns. Polar pattern. Polar pattern determine how your microphone picks. That is it. This is a dynamic microphone. A dynamic microphone. If I use this mic like this, it's not going to pick jack. And if it's speaking, it will be like you are whispering. It has to be used like this, because it's because of the directional properties, because of the polar pattern. It picks up sound from the front. So sometimes it's not about the engineer bringing up the volume. You see somebody talking and holds mic like this, and the engineer bring it up. Tell the man to use his mic like this. So if you can go and get away with this, if you hold a condenser mic, can get away because it's sensitive. Condenser is sensitive, regardless of the polar pattern. So the directional property of a mic matters. This is a unidirectional mic. It has to be used this way. So it's a dynamic mic, but it's a unidirectional. Those are the polar properties. It has a heart shape. Let me see if it's drawn here. Some of those mics you will see the good. You can see the shape. Okay. When we get to, you can see the shape. Look at it here. Yes, cardioid. So cardioid, that is heart shape. This first one. This is a directional property. If I pass this mic around and you see the shape, it's not for people who just see it, you think it's just design. It's not design. They are trying to tell you that this mic is a cardioid microphone. And when you go to use a cardioid microphone where you're not supposed to use it, you have problems. So cardioid heart shape rejects sound from the rear. That is it. Okay. It rejects sound from the rear. Then supercardioid, tighter front pickup, some rear, some sensitivity. Then omnidirectional. Omnidirectional. This is omnidirectional. The cycle 360 picks up sound around, and that's why I can cheat with this kind of mic. This mic, the lavalier I'm using, is an omnidirectional mic. That's why when I'm using it, even when you talk here, you can still hear sort of. It will pick it. Sorry, you can pick. It can pick it because it's an omnidirectional. But it has its own disadvantage too, meaning it has a high tendency for it to feedback because it will be communicating with the monitors or the speakers around you. But when you use it in a studio setting, you won't have that challenge. So you need to understand your mics. Then bidirectional, meaning it can pick up sound from two sides, front and back. Front and back. We have a bidirectional mic on stage. Shotgun, I'll explain that. Extremely narrow pickup for long distance sound. That's how we use it. And very sensitive. That mic, that shotgun. It's a very good mic. Most of the movies that you watch, they use shotgun. If you check the making, shotgun mic they use to pick up. And it's going to pick up healthy sound. It's like it will focus itself on the where the sound is coming from, the direction of the sound, and pick it up. So those are the different kind of polar patterns: cardioid, supercardioid, hypercardioid. So when you want to request for a microphone, maybe for a condenser mic or dynamic mic, you should be conscious of the polar pattern, the directional, so that you don't go and buy a dynamic mic, very good mic, but it's omnidirectional. Meanwhile, you are supposed to buy a unidirectional. Very, very important. Very important. Like for a lab now, I would prefer unidirectional. The only disadvantage of that is that by the time I tilt my head, you might not hear. I will lose some speech. That's the only difference. But it's better in a studio setting. In a studio setting, it is a unidirectional. A news presenter, a broadcasting, a TV presenter, we don't have reason to be turning around. So the TV presenter will just stay and be reading news or watching the screen in front of them. So with a unidirectional mic in that studio, we are good to go. And it's not likely to pick anybody talking around. So let us. Okay, question.
All right, so it says, how do you properly and effectively manage feedbacks from sensitive microphones without losing out on audibility and clarity?
Okay, when we get to mixing and stage, we will deal with that. However, I will explain. There's something called gain structure. Though the question is trying to move us away a bit, but let me just explain. There's something called gain structure and your sound tech and your balancing. When you gain structure, you ensure that you dip some frequencies. There are some certain frequencies that you don't need in that microphone. Imagine having a 60 hertz on this microphone. You don't need it. Or 250. You don't need it. So those are the problematic frequencies that anything you don't need in a microphone, you dip in it. What I mean is dipping, you bring it down on your mixer, your EQ. The EQ is equalization. So you bring down your low mids, your whatever, frequency that's affecting you. So that is how you don't have feedbacks. So then you minimize the level of that microphone on your monitors. You minimize it. You just there's something called hearing level sound. If we can hear, like now I'm speaking, I'm not shouting, but I believe all of us can hear me. So hearing level. So once you bring out that once you set your microphones, your lab on your monitors to hearing level, and you have deepened those frequencies that you don't need, you should be fine, and you still get healthy signal, healthy sound. So I hope that answers the question the person asked. Oh, okay.
The supercardioid and the hypercardioid are quite similar.
Yeah.
So
Okay.
can you just distinguish the difference?
It's basically the same, supercardioid and hyper. In fact, that's why here you can see that the slash supercardioid and hyper is just like an improvement or more details than the supercardioid. It's the same thing. It's basically the same thing. Though the hyper is a bit, it has a more tighter, it has a tighter front pickup than the super. But yeah, you can use them interchangeably. They're basically the same thing. And what it means is that here you still have a bit of pickup. Here you have more of this than this, but here you don't have anything. So that's it. So it means, and this is it, what they are saying basically. If this was a cardioid microphone, here you won't get any, no sound. Even if when I come, I try to speak to it, no sound. But with a super cardioid, you still have a bit of sound filtered through here. So that is what it means. You can see a shotgun. You can see a shotgun. Look at the way it's picking sound. So that's why it can pick sound from a distance and all of that. And it's not narrow. It's not like round and this. So it picks both from almost all the sides. And that's why when you remove that foam on the mic, you can see where the grill is on that that microphone. Figure 8. That's bidirectional microphone, meaning it can pick for the front and the back. It's usually flat microphone that stands. Both of us can be using it. You can be speaking from here. Yeah. Yes. Yeah, that's it.
The omnidirectional
Yes.
and the shotgun.
Yes.
And you said the shotgun picks from a distance.
Yes. Narrow.
Now, the omnidirectional too.
Yes.
It's the same.
Yes.
So obviously, I don't know.
Okay. You want
What
to
is
differentiate
between the shotgun
this
and
omni. This omni can't differentiate. It will just pick, and it has a larger coverage, unlike the shotgun. Shotgun, you can see that all these sides are dead zones. They are dead. Unlike the omni is picking. Even somebody that is there it doesn't concern us. It's picking. But if I put a omni a shotgun here now, that sweeping, the sound of that broom, we are likely not to hear it. But omni, we pick it. If this is recorded, I can bet you that this is my microphone. Likely to be picking something over there. So those are the things. But that shotgun will just pick something immediately, something that around. It will not go far from that range. That's why when you see when they use it, they point like this. They point towards a hand. So it will just pick around, and that's it. That's it. And it has a kind of narrow hiccup. So it speaks like this one. I think it's just a technology. So it's designed in such a way that it's going to sense where the most sound is coming from, and it just pick it out. So, and it's going to be clean. And the best time to use like I'm using it right now. And you can use it an audience. Okay, yeah. You are just concerned about this figure 8. It's, do, do, do this guy, I think it will pass. It will pass for bi-direction, but it's not basically bi-direction. Yes. Because it can even pick. Yes, most bi-direction. This is how the shape is like. because this guy can pick, if you pick from like this, from the front. Yeah. No, 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 no. And it's a dynamic microphone. It's not a condenser. Okay, question
All right. So it says, which of these kinds of mics are best for singers?
for singers. SM58. SM58. Then dynamic. Then, but if you have a group, if you have a choir, condenser microphone like this shotgun is good. It's a condenser mic. It's not like to be a shotgun. I'm just using that as an example. Any condenser microphone is good for mass choir. Yeah. So, but for vocalists, especially solo vocalists, dynamic microphone, your SM58, your wireless microphone, those ULXD, I don't remember their names right now, but most dynamic microphones are good. But don't use SM57 for vocals, except it's for instruments, except there is no means. You will still hear the sound, but it's not the ideal application. Not that you will lose some frequencies. You lose some frequencies.
All right. So does a shotgun have a different polar pattern? I thought you
Yes.
said it's a type of microphone.
Yeah, now confused. Yes, it has a different polar pattern. It's not like it's a type of microphone. So it has a different. That's the polar pattern on the. If you can see the person on the online, that's the shotgun. That's the polar pattern. You can see the difference. People tend to mix up type of microphone with polar pattern and all of that. So if you know what each does, especially this shape, if you know it, then you can choose your microphone yourself. If you can define it and choose the application. What the person selling, you just want to sell microphone. What's you search now, you research, you ask before you go, you know before you go. Then sometimes don't be surprised, some of them to know. They know, but they know you don't know the difference. They can sell condenser microphone for you. So, but most of the time, the high-end microphones, most of the time, those that sell the high-end microphones knows all these things. They know it. Like the main distributor of Shaw in Nigeria, what's his name? Shaw Gear. He knows all these things. They know all those things. They know all these things. So, and all those microphones have their own frequency range. There's another aspect of sound again, so that you don't mess your job up. There was this experience that they did, I think 2 years ago. Okay, let me not go into that because I'm online. So let me not go into that. But there are some technical things that can go wrong. Okay, so no go there. Okay. What? Sorry, I didn't plug this. Excuse me, please. Choosing the right microphone. Okay, I think this will answer the question of the person that was asking the type of microphone. So, vocals condenser, which is studio, dynamic live. You can see so you can see your guitar dynamic. This is the SM57. You can use it for instrument mic, just acoustic guitar. You just put this on a mic stand, point it towards the where you strum, and you're going to pick it up effectively. Podcasting, we've talked about this. Then field recording, shotgun, shotgun mic. Then your portable zoom. We also have the zoom here, zoom H. So key features to consider: frequency response. This frequency response is very important. How the mic captures highs, mids, and lows. You see, many microphones has frequency response. There are some microphones you can only capture from 100 hertz to 2,000 hertz. So if you go to buy those microphones and you want to use it for your kick, you are on your own. No, okay, it can still work. No, it can still work for it. Yeah, no, it can't. No, it can't because it's subwoofer. So they have frequency range, meaning that the microphone can only produce from a certain figure to another figure. So those are the frequency response. Yeah, but most microphones can produce, especially vocal microphone can work between 100 and 6K most. So you need to be mindful of that. Then sensitivity, that is how well your microphone picks up in quiet sounds. How well your microphone picks up in quiet sounds. That's the sensitivity. Then SPL, how loud a source. Somebody's online. So how loud a source it can handle before distorting. This is what I was saying. When you shout on a condenser like this microphone, when I shout on it, it's likely to distort because it's quite sensitive. Yeah. So low impedance mics and all of that. Okay. For Foley, it's condenser microphone for Foley. And in fact, the person that asked the question in the spirit, and that's where we are going now. I want to play a video for you so that you understand that fully. For those that don't understand fully, that Foley is somebody's name, John Foley. Where is this guy? So I can play video, right? I think we tried it the other time. So you see how they make movies.
In Hollywood, everything is magic and make-believe.
Gloves with paper.
Why is it? Okay, no, is this second one? The second one. No.
Clips are dog paws.
Even what you hear.
We are storytellers with sound. Over here we have a feather duster used for bird.
It's playing online.
We bring sound into the story and we can create any mood with that sound.
When you watch a film, much of what you're hearing was created.
Your sister. Okay.
From footsteps.
Yeah.
On a snowy path to a vicious thunderstorm.
Weather is a...
In Hollywood, everything is magic and make-believe.
Gloves with paper clips are dog paws.
Even what you hear.
We are storytellers with sound. Over here we have a feather duster used for bird wings. We bring sound into the story and we can create any mood with that sound.
When you watch a film, much of what you're hearing was created. From footsteps on a snowy path to a vicious thunderstorm.
Weather is a really interesting thing to recreate.
And make it exciting.
It depends on the elements that we're using and how it's filmed and what they want to hear.
Here at the Warner Brothers lot, Foley artists practice their craft. And if they do their jobs right, you won't even notice.
People take sound for granted, but you would miss it if it wasn't there. Foley is the art of sound. It's creating sounds in sync with what's happening on screen. The art of Foley goes back to the old radio days where you would see the sound guys with their clomping with their coconuts. This is what we use for horse hooves. They're plungers, and we stuff them with cloth and a little tape. And here we go. Jack Foley came in and he thought, if I do those sounds in sync with the picture, I've just taken a whole step out.
Jack Foley's legacy in sound began in the 1920s as talkies swept Hollywood. Ever since, the reproduction of sound effects added to film in post-production is called the art of Foley.
The Foley stage consists of different surfaces.
This is walking on leaves or in a forest. For snow, what we normally use is regular play sand. And then to add to that, sometimes you hear that familiar crunch, which we use cornstarch. Your ear hears snow, but in actuality, it's sand.
It's almost like a prop house. We have collected different things because everything here should make a sound. Here's a classic squeaky hinge. Pine cones can be used for cracking ice.
You have the three people that are on the stage, the mixer and the two Foley artists, which it's important that you have a team that's cohesive.
You know, something's cracking, popping, I don't know what it is.
Is it this? Sometimes it takes a little trial and error to see what works best. Hold on.
We have a streamer that goes across the screen, and when the streamer gets to the end, that tells us when that sound should start. It's an interesting dance. There's really nothing that we can't do here imagination-wise.
Right now, we're in the control room, and it's where I mix. And I listen to them performing to the picture. I try not to look at them because I really don't want to see what they're using. I want to see how it sounds.
All sound is two elements hitting one another.
With rain, if it's hitting a puddle or if it's hitting someone's face, that's all going to sound different. So those are very specific little things that we have to watch and look at. Okay, Mary Jo.
Here we go.
Wind is interesting because it's usually what the wind is blowing through.
Allison's going to use the Batman cape to create the sails, and I'm going to create the boat actually going through the water. Okay, let's go.
If we're doing a boat going through waves, we would use the big tub that we have to get that slapping sound, or churning up the water a lot in the tub with our hands.
It's a lot of sound, like a lot of things artistic, is very subjective. So I have to make a judgment call. There's a great moment when you get the perfect sound, and they don't always know it, but I do.
How was that, Mary Jo?
Sounded great.
When there are multiple weather elements involved, we might do all the specific things first, and then go back and do maybe a general sound. We have a shot here of a hiker coming down the waterfall, so I'm doing the sound of the carabiner and his rope and his equipment. How was that?
That's cool. So I'm going to play it back all together and see what we've got.
We really layer everything so the mixers can mix how they want to hear it. And we do things also that are a little over the top because we have to fight with music, sometimes dialogue, but hopefully when you hear it at home, it'll sound just like it should be, natural.
Now you get hello? Okay. So you get to appreciate You get to appreciate sound better now with this. So that's what they do. It's just that it's budget and being lazy around here. That's why we don't get some of these things. They are very, very detailed. So they take that. That's why their movies don't just come out. Like they can be acting for like 3-4 years, because it takes time to do this. The sound guys need to watch those movies. After watching, they now begin to get get the apparatus and whatever objects they need to create that effect. So, and that's when you watch it, you feel, because if there is no sound, if you don't have those departing footsteps and all of that, you won't understand. And sometimes too, they use what's it called? What do they call this thing now? Samples. Some of these things too have been recorded. They have samples on them, so easily they can easily look like the thunder, and they can easily use sample. But there are some you don't have sample, and again, it needs to sync with what you are watching. So that is how, and those things cannot be. You can't appreciate those things. They can't get those things right without a microphone, especially the appropriate microphone. We can see microphone throughout that distance. So, and that is how that's how it has been working. Now, coming, I wanted to show us. I don't know how I jumped to this. Where is it? Okay. Yeah, I forgot this part. You see, after your event, power down equipment in reverse order. This is very important. It was when I was trying to pull out that cable the other time that I remembered that I didn't touch this. So in sound, especially live sound, when you power up your mixer first. Your mixers first. If you power up your amplifier and your speaker first, then what you hear is a loud noise like a bang, and it's destroying the diaphragm of those speakers. And when you are shutting down, you do it in the reverse order. You put off your speakers first, then the mixer. It's very important. That's part of the basic sound, whatever. But I just felt I should chip that in. So we have come to the end of the class. Does anybody have any question?
So is there a way we can actually get the video of this class on the platform for us to like do? Thank you very much for the training. It's very explicit. My question is that you made mention of front of house and stage. So my earlier days in the department, I get it confused. Why front of house and why stage? What do they do? Are they doing the same thing? If they are doing the same thing, then why do we have to split them? If they are not doing the same thing, when is it necessary to have it that way?
Very good question. So, like the basic term that I just use for a layman, so that for anybody to just understand on the go. I normally say front of us is all the speakers facing the audience, and stage, all the speakers facing the stage. That's how to differentiate. Now, we have some speakers on stage, and basically, what they do is that they are monitors. They are monitors. Is to guide whomever is speaking, because those are speaking on stage. They are behind the speakers facing the house. They will necessarily not hear themselves clearly. So what the stage does, that you mix for stage, you mix for those that are on the stage, so that they can be in sync with whatever is happening, especially when it comes to music. Now, then the other distinctive aspect of stage is that, for example, a singer, somebody is singing, and we have instrumentalists playing, and the guy does not want to hear maybe the bass guitar. You can achieve that with stage mix. So I'm singing now, I don't want to hear the bass guitar. I just want my keyboard, my drums, and my backup on my monitors, on my own speakers, then you can achieve that with stage. You can remove, but you can't achieve that with house because you are not do you want to those in the house need to enjoy the entire mix too. Because the person mixing for the house, you want to mix across board. You need to hear whatever is happening. You want to hear everybody balanced mix. So you can't achieve that with we can't do that with front of house, but we can do that with the stage. Mix minus. You can remove something, bring some things in, and all of that. So those are the distinctive aspect of stage. Now, can you use a mixer, a single mixer, to achieve that? Yes, through auxiliary mix. You can do your auxiliary. You can be using the same mixer to mix stage and house at the same time. However, for a big environment, for a big show, you can't. It's not proper. It's not professional. It's not industry standard to do that because you run into a mess. Because already the show is a big show. So you have to look at our concert now. And it's a single engineer want to mix for about 30 instrumentalists. And he wants to also to mix for the audience. He wants to balance those guys and want to balance the audience. It's a lot of work. So it's not advisable. So that's why we split it. For a smaller venue, you can do that. You can just have one mixer and you will still achieve it. So those are the differences between stage, and that's why we have two mixers. You have a mixer over there, and we have one here at the bridge. But when we get to mixing, because I'm going to still take mixing, I'm not sure, maybe it's next class or the upper Saturday. So we'll go deeper into that. Today we're just focusing on the microphones and the spectrum.
So, says please kindly expatiate on the power up and power down using Daystar as a prototype. Sir.
Okay, using Daystar, well, it's not necessarily Daystar. It's anywhere in the world, anywhere. How you just need to power. Whenever, just put it at the back of your mind. Whenever after you've set up your equipment, you can see those people. By the time we listen to this recording, that noise, this microphone would have picked it because it's an omnidirectional mic. So, sorry to be distracted. Now, for the powering up, after setting up a basic setup, you have your mixer, your speakers, and your amplifiers. Mixer, speaker, amplifier. That is what you have, regardless of how complex your sound is. I normally tell people that in sound, you just have this: your input, your process, and your output. It's as simple as that. The input, the process, and the output. When we get to mixing, I'll talk more on that. So now, when you want to power up, you power up the mixer first. Your mixer, you power it up first. The reason being, if you power up your speaker, the speaker is already trying, or your amplifier, because now I want to go more deeper. We have passive speakers and we have active. I'm already doing another class. Active speakers are the speakers that have inbuilt amplifiers. You just, like this guy is an active speaker. There's no amplifier, separate amplifier. It's inbuilt. And we have bigger speakers too, like that. Main PA systems that are active. So you don't need separate amplifier. The speakers are self-powered. That is active. Then we have passive, whereby you have your amplifier separate and your speakers separate. So the idea is that when you just power up the speakers without the mixer, it's already trying to take signal. So, and once you power it up, the only signal it can produce is the noise, that banging noise. So that's why you need to power your mixer, because your mixer is already connected to it. And if your board is muted, not everything is down. If you step down, it will attenuate that bang that should come. So that is it. That is it. You can hardly hear that in Daystar. You hear any speaker bang. But I go to venues, I go to places, and I hear that. I say, these guys are committing mistake. They must have powered this thing wrongly. So you power your mixer first. But when you are shutting down, it's the other way around. You power the amplifier power down the amplifier first, either the amplifier or your speaker, because they are the same thing. They are the same thing. If it's the amplifier that is driving your speaker, you power the amplifier. If the speaker that is driving itself, you power up the speaker. And so that is how it works. That's why when you are here on the Sunday, when we are shutting down, you see the engineer here calling the engineer on stage. Have you powered up the amplifier? Have you powered up amplifier? Because if this man just by mistake off this mixer with the amplifier still on, oh Jesus, you won't even like yourself if you are doing on. Because all the we have about 16, what am I saying, about 25 speakers here. Everything will respond at once. Wow. And with that, some diaphragms might have fried. So that is it. So it's a standard anyway. It's not matter of Daystar anyway. Yeah. I go to gigs. I work some other places. I go to some churches maybe to resolve some issues and all of that. So I still follow that process. And if they've been doing it wrongly, I still advise them to do it. So, like this picture now. This praise blast. That year, I did a stage mix there using Midas Pro 9. So it's usually a December event where they bring A-list artists. So it's the same standard everywhere. Any other question?
All right. So the person said, I thought the amplifiers powered the speakers.
Yes, the amplifier powered the speakers, of course. But your mixer sends signal into it. The amplifier is just to power the speaker. It's just like your car. Your engine is there. Kill on shaking it, don't touch. We don't need it again. Oh, okay, we need it for kill on touch. Oh, okay. So is your amplifier. It's just like your car engine. Your car engine is running. Yes. I mean, your car is powered by the engine. But until you engage the gear before it drives, if you just start your car, the engine is running, and you don't engage the gear, it will not move. So the same thing, your speaker, yes, this thing has powered it. The amplifier has powered your speaker, but it can't do anything by itself. It's the mixer that will now begin to send signals into it, except you want to send signal into the amplifier. And that one will be limited because you can only send into one channel of the amplifier. And you can't plug any other thing, but you can plug all your microphones on your mixer and you'll be controlling it from there. So, another question?
Yeah, so it says...
Our online folks are asking more questions.
Right. So what if we have both active and passive speakers with amplifiers as well? How do we ensure that we follow this procedure?
It's the same process. You will just go to the switch and put it off. You just go to this and it's the same process. It's the same process. You will just put it off. Just put it off. You just put it off. It's the same process. Just to know where your power on and off button is. That's all. So I think we have been able to, like I said, please, with time, we'll be conscious with time. We are done now. So that everybody can plan. If you have any place to go, you already know that this is the time. If you so you can plan. We are done for today till Saturday again. So if you want to join us on time, so that you don't miss any class. It's for planning purpose. So thank you so much. And if you have any question, you can still see me to ask question. You are free.
Thank you very much, Mr. Micheal. Thank you. Please, if you have not filled the attendance, I think it's a link, Abby. Yes, please. If you don't understand how it works, see Mrs. Amanda. So we'll be meeting next week Saturday, but please.